Today's going to be on beam and shell meshing using Workbench Mechanical. So if you're a New York or New Jersey resident, you can earn continuing education credit for attending this webinar. Ask that you participate in the polls and complete the survey at the end of the webinar. And you can always check us out online too. We do have our schedule of the other upcoming e-learning webinars. Some of the next ones we'll be having are how to use the Engineering Data Manager, element selection, assembly modeling, and using preloaded joints. So again, check us out online at CAEAI.com. So everyone is muted, so if you do have any questions throughout the webinar, please submit those to the chat window. And if we have them at the end, I'll try to answer them. Otherwise, I'll just follow up with you through email. So this is also not really meant to be a training session. I'm just going to show you some of the different features available in mechanical. You're meshing with beams and shells. So I'm going to use two different models. The first one is going to include continuous mesh between some beams and shells connected up at the geometry level. And this model will be just a shell model, but we're going to connect everything together at the mesh level. So that's what we'll be doing today. So let me just switch and share my desktop with the first model. This one to start. So this is the quarter symmetry model of a tank. I'm using Space Claim. You need to get your geometry from somewhere, from CAD, Design or Space Claim, to create your beam and shell model to bring it into mechanical. I like to use Space Claim because it has a feature that makes it very easy to extract from solid geometry, which is what I have here. This is solids, the beam representation of that. So using it takes the body and compose it down to a beam. And if you zoom in, you can see the beam that's represented and then also the cross-section that comes along with it and its orientation. So this makes it very quick and easy to convert solids into beams. And this could also have some whole regular shape to just kind of takes the average of it. And you can always look at the cross-sections if you wanted to and modify them if you'd like. Those are all there. So that's good. We've got some beams in here. The next thing is I will take these other solid bodies and then get a mid-plane surface out of them by identifying those surfaces. There is an automatic way to search through all the parts here, but I have a couple, so I'll just do that manually. So then down here again, you can see this body that used to be there, and now it's represented by this mid-plane surface through there. So when I do that, though, the model there, these were touching before, so now I have a gap between these parts. And I have this be a continuous mesh. So I want that beam element to be meshed, shell elements in there. So that I can do that is to just simply grab these beams, grab this one and the other one that I have down here. These are the same sections, and then also these plates were the same thickness, so I can just grab them both at the same time. And if I offset these elements up to this surface right here, which is 3.5 inches, so I'm just going to copy that dimension and move here. So now on line, but that cross-section is not where it used to be anymore. It's shifted up. So I'm going to put it back to where it used to be. So I'll just get these cross-sections. I select that one and the one I have here, and move those down by the amount that I grabbed before. So you can visually see where that cross-section is aligned, but the beam element is integral with that surface right there. So that's good. That's where those need to be. So there's a couple other things I need to do before I bring this into mechanical is that there's a gap in between these surfaces just because it was mid-surfaced. So I'm going to pull those surfaces back up to be matching with each other. So then those surfaces will share the mesh at those locations. So I'll just grab that surface and move it up to that part. So good. And then same thing with these beam elements. They well. So you can see the plates in there, and those are connected. And then one last connection here. I'll just manually do this. I'll click these to each other. This is good. Everything is now touching at this point. I want these to be meshed all continuous when I bring them into mechanical. I just need to do one on the assembly level of this part to just say that share the topology when I bring that over. So that's good. This is all set. Let me just quickly, before I import it, I could bring this from Space Claim directly into Workbench through the here, but I already have it open. So I'm going to then attach this model to the project, the active generator I have. So it goes up. Since I'm bringing in lines and surfaces, I just need to make sure that in the details of that, I'm also bringing in the line bodies. And since they're going to be mesh continuous in lines, I need to set the mix import resolution on that to surface and lines. So just open this up in mechanical. While that's opening, I'm going to first poll here. So let me stop sharing this and open up our first poll. Come on. So the first poll question for everyone is, how often do you perform an analysis that uses beams or shells? So I'm putting this poll up to you. Hopefully at the bottom right of the WebEx window, I could see a polling window. So if you go ahead and submit your answers. That's good. A bunch of people are already participating. It looks like the majority have submitted theirs, but some are still working. I'll just give you a little time here. And everyone's probably submitted theirs. On a poll now. I'll see with you the results. So how often you perform analysis that uses beams or shells? Looks like 50%, less than 10%. Majority is about 10 to 35. So I guess it's not as common as maybe some of the other analyses, but okay. Well, let's go back to mechanic. Should have imported by now. Okay, this is the geometry that came in. I'm just going to take the default mesh on model. And all that one, we can look and see that we have some mid-surfaces that came in. There's also some thickness associated with those. And beam elements do have some cross-section properties associated with them. So if I mesh, we can see that these are shared at these locations. However, if we turn on the display of beams and shells, we can see what this actually looks like. So we can see that these cross sections are aligned where they used to be in the geometry, but they are connected up at the mesh level. So that's nice and easy to visualize that. Same thing down there; those are all connected up. So the fairly straightforward. If you bring it in and everything's connected, you can just go ahead and mesh it as is. So let's take care of things on the CAD side. We do need to bring in these beams and surfaces from somewhere, CAD, design model, or Space Claim. So let's go to the next part now. Where we have, this is a half symmetry model of a trailer hitch. These are all surface bodies that come in. If I open the design modeler, you can see that these are all surfaces in here. And these are mid-surfaces that haven't been modified in any way. So there are gaps between these parts where this used to be a solid. And so these surfaces are not touching or connected up in any way at the point. Same thing down here. There's gaps at that location down here. So we're geometry into mechanical as it is. So that, just first take the default mesh that we'll have here. So let's generate that in a second. But so why don't we take another short poll? So open up the next one. Okay, poll is how do you obtain your geometry for beam or shell meshing? So it's up to you. Go ahead and send your answers. You've already submitted yours. Good, we got over 50%. That's good. The majority of you have already submitted your answers. I'll give you a few more seconds here. Okay, everyone that's going to participate has, so let me close this poll. Share with you the results. All right, so this one looks like a pretty much majority is using the CAD system. Definitely available to you. There's mid-surfacing, operation there, and built into the CAD to bring over that geometry, as well as Design Modeler. Actually, none have used Space Claim, which is what I showed. Again, I only like to use that just because that beam action utility makes it so easy to set that stuff up around. But any will certainly work. So great. Go back to Michael now. We should have a mesh on our part. And so let me also turn on, well, I guess we can see here right away that at these locations, these parts are mesh continuous. They're not connecting. You can obviously see the gap there. But turn on the thickness of these shells. Let's closely represent what the part would look like in real life. They're not connected right now. So go ahead and connect this stuff up at the mesh level. And with that mesh connection. So that's a connection group, and the type of connection group that's going to be is a mesh connection. So within some tolerance, meaning that basically the separation between all these bodies, we're going to look to indicate a connection between, and that's based on the radius of this. So that gap that's in here will certainly be encompassed by that 2-inch. So let me generate these connections, and then I'll rename them based on their parts. So we have a bunch of mesh connections in here. Well, what is a mesh connection? It's an operation that's done post-meshing. So it's modifying the existing mesh, and the way that it does that is to basically merge the nodes together. It does that. It's holding one set of nodes in place, and it's treating the other ones as the nodes that will be merged into the other parts. So master and slave. The master in this case is that surface, and the slave are these 3 edges that are shown in here. So this means that those slaves are going to move into the master. So all the nodes on that edge are going to move up into this part based on this tolerance, this sphere. If I was going to put a kink in here, it's going to take these nodes and shift them over. I'd really want to take the nodes that are on this red surface and then extend them down here. So I really want the opposite of what's shown here, which is actually the next one that happens to show up. So I'm going to delete off that first one. I just don't need it. You can see that master is now this surface, and that's the slave, the edge. So those nodes will be moved down into this location. That's good. That's what we'd like. The next location, here are going to be all these edges along these top merged into that surface. It's missing the surface in red here. So let me just add that to the existing set in there. So that's what I'd like to have. This next location down here, it's probably on your screen, but we have that show up down here in this. So you can easily see it here a little bit better. I'm just going to grab all the edges that go around this part. So all are now going to be merged into the red surface here. And, you just have to see what you get in the automated way. This next here, this is redundant as well, so I'm going to delete that one. This this bottom edge here was already included in the previous one we saw. These next locations are all good as is. So this we move down to that edge, move down to that surface. Same thing, the edges through here are going to be connected up. So options here. If I show the mesh for a second, you can see that it really be if these surfaces were allowed to interact with each other. And we want to have a mesh connection between any of these bodies in here because there might be some slow bonding. So these connections that are these two in here, I'm just going to delete them because I'm going to connect that up. So doing interaction between these surfaces, we can just put in a contact to handle that. And that's another connection group. So if I insert connect, and this is contact again, search between all the bodies that are within some tolerance. In this case, they 0.2, and generate our connections. One shows up. Let's rename that's shown here. So these three surfaces are going to interact with the blue surfaces on this other part here. And I probably want to include that blend as well. Just grab those faces and add them to the target segment. Now those will interact. We'll do that as bonded for right now. I can change that later on. So now let's see what happens when we put in all these mesh connections. So let's update the existing mesh. And I generate the mesh. It says it's connecting the mesh. It's not going through and remeshing this entire thing. We already have a mesh on here. It's going through doing all those merging operations there. So this is a post-meshing operation. And while it's doing a thing, let's take our last poll here. Finish, but I'll take another poll. So let me open this up. Okay. The poll is: what's your biggest challenge for beam and shell meshing? Go ahead and read through all the answers, and here's one so you get a chance. About half of some of their answers, so we'll just give a little bit more time here. Yeah, like pretty much everyone that is going to participate has, so I'm going to stop the poll. See the results. So that's pretty spread. It looks like it's more dealing with the geometry end, setting up surfaces, getting mesh to connect together, and some of it is getting a good mesh. Getting the good mesh has to do with setting up a lot of mesh sizing and things like that, but a lot of ones are starting with more contact, dealing with geometry and so on. So it's kind of a strong mix. So let's back to one. And I'm going to turn the thick. We can see what happened here. So if we look here, we can see that this edge has now been brought down and merged into the mesh that's on the surface in here. Down the edge, it's a little crooked, but not too bad the way that it projected out on the surface. If we look at the location down here, this one up pretty well. I can highlight in green what the geometry used to look like. So you can see that existing mesh was just cut out to this was on this other surface. So geometry still has the gap in there. It's just the mesh was taken care of. And location over here, with this around, it could be a little better than that. So we'll take the time to fix that up a little bit better. This is just what we're by doing now. It's just taking the defaults. So one of the mesh connection is that it's taking the edges and it's extending them based on this tolerance in this sphere over to this surface. Also a snap type, so there's one tolerance that goes this way and another tolerance that goes up and down this way. So these connections are going to change based on the mesh density that you have and the tolerances that you set up. So this is just what we happen to get, nothing else. So this location here, it's maybe a little bit easier to see if I turn on the edge coloring in here. So these edges here are triples. So this surface, and the surface that's up here, those are all connected at the mesh level. Like the same thing. If we look here, we can move this back down here. There we go. You can see that those are connected with the coloring. Maybe you need to see it. So let's fix up this location in here, because we could make this a little bit better. This is just geometry a little bit. So if I design modeler, I have one big long surface that goes through here. This could be meshed free however we would like. So if I go in and just slice this body and slice this surface right here, so it'll put a nice split along here and then just form a part. So that's a continuous mesh, not an edge that will show up in here. So again, refresh this geometry. Only this one post in here changed. So that's the only thing that needed to be refreshed. So that's the only that updates. The mesh still stays on these other parts. So since I've heard of slicing this up and this edge, I'm still going to use the mesh connection, but I can make this connection a little bit nicer too. The way that I can do that is we just start off by getting all the other stuff other than these two bodies here. I'm just going to look at it down axis. So one edge right at this location shown in green, and then I have another edge right here. So I'm going to try to take and merge the nodes that are on these different edges together. It'd be nicer if this one edge was similarly shaped on this opposite side here. So if I have these three edges, I can use a virtual topology, and I can insert a virtual cell, which joins all those edges together. And then at the location where I have a vertice, I can just click on that line and then split the edge at that location. So now I have a split down here as well. I'll do the same thing over at this location. I'll just click the arrow and insert a split. So now one edge through here and one edge through here. So I put on a consistent number of element divisions through here, and it's up a little bit nicer. So just insert a sizing on those two edges, and I'm just going to put in some number of divisions. Maybe say 6 divisions. So now we're controlling this a little bit more, say, the way that we would like, with those in there. Of course, since we updated the geometry, we just need to reassociate this mesh connection to the changed geometry. So there used to be these surfaces shown in red in here, but instead of surfaces, I want those to be the edges that I just put in through here. So the nodes that show up on these edges will stay, and then we use these other 3 edges here as the slaves, so its nodes get merged into that. Give it a little bit more control over this mesh connection. So just update mesh. And when I'm updating mesh now, it has to remesh this one body here, down here, and this plate that is in here, because I use virtual topology, and these are new geometry that came in. So you can see it's generating mesh for those 3 parts. It doesn't have to regenerate the mesh for these other bodies that are in here, because I update them. No geometry changed. The mesh stayed on them. So there it generates the mesh. It does the connecting, and it saw that it was connecting it up in there. So this location down here, we see what happened. If I hold it and see across here, those that surface is nice and straight now. That's what it would have been like in the geometry. Now that's what it's like in the mesh when we connected it up. We put in some sizing in there, so it's a little more refined. We could certainly go through and put on a lot more sizing controls and meshing and things, and all this stuff look a lot nicer than it is. But that's what we get if we do nothing else. So now this location was over here. Highlight so we can see this, and turn on the thick shells and beam just so we can see this. So I have some contact defined between this the host here and then this other cross member. So it's a contact right now. That's probably not really accurate as it could be. We could model this a little bit better. Say there would be some bolts going through these holes. So we insert manual contact region where these two edges on this one plate would maybe be bolted to the other edges on these other holes. So then these two holes are going to be stuck together. These two holes are going to be stuck together at the edges. That might be a little bit better. And then if we do that, and maybe we want to run this as a nonlinear analysis, we could switch this bond contact over to frictionless. So these want to interact with each other, we'll be allowed to do so. However, when we do that, we see that there's some contact, I guess, surface that need to be defined to either the top or bottom of the shell elements. So what that means is if I look at the mesh, the geometry is at the midplane right now. So that's the surface that goes through here. And this shell has a top and a bottom associated with it. So is this the top? We want to bond to the bottom of this body over here, or bottom to bottom? How do we know what we need to set in this contact pair? Well, the way that we can figure that out is surface bodies have a normal direction. And normal direction is identified by the green coloring of the surface when we click on it. So, I'm on the surface section, highlight this body. This is the green surface that I can see here. So that's positive normal direction. So for this surface, the positive normal. So then the far away would be the top of the shell, and then in the negative direction is the bottom of the shell, the farthest away. So for this body contact, I need to set to the bottom, and then same thing on this body over here. I highlight this surface. This is the top, positive direction, and negative is the bottom. So this also needs to be the bottom. To do that, you can also see that the coloring of the surfaces change. So now these are colored, pointing at each other. And you also do this another way too. If you just highlight on those surface bodies where the offset of these shell sections are defined, we could set them to be the bottom. If we go back to the mesh, we can see here that the sections have been offset. It used to be at the middle for the midplane. So the middle of the shell section was aligned with the surface body right here. So now set it to the bottom. So the bottom of the shell section is aligned with the surface body. So that's clear bottom. And on this side, that's clearly the bottom. So easy to check that too. Or if you wanted to include some offsets in the sections, that's how you could do it. Set these back to middle in here. So text setup, and we could go ahead and solve this analysis if we'd like. There was one mesh connection up here that, since I changed this geometry, I would also have to redefine up here. But this would be good to know. So actually, it's 12:30 now, so that's all the time that we have for this webinar. We went through a couple things. One, meshing with beams and shells, connected at the level, connected by setting CAD, so it would be all connected. And then we use this part here, where we connected it up at the mesh level, and the separations in it. So thank you for attending. We'll answer your questions through email, so I don't have to keep you on the web longer. So for attending, enjoy using Workbench Mechanical for beam and shell meshing, and check us online for the upcoming e-learning webinars that we'll have. So thank you.